In this topic, we'll be exploring how chemical bonds are formed between atoms, holding them together in substances. Atoms are either metals or non-metals, and therefore, as you can see, there are three types of bond possible. The simple answer to why chemical bonds form between atoms is because they can. Atoms use their outer shell electrons to form bonds, becoming more stable as a result. The number of outer shell electrons an atom has limits the number of bonds it can form. This idea is called valency. The valency of an atom is the number of outer shell electrons the atom uses in forming bonds. We can see that this is reflected in the periodic table. Atoms in groups 1 to 4 use all their outer shell electrons to form bonds. Atoms in group 5, 6 and 7 can gain or share 3, 2 or 1 electron respectively. The atoms in group 8, also known as group 0, have full outer shells and tend not to form chemical bonds. The bonds which form between metal atoms are referred to as metallic bonds. The bonds which form between non-metal atoms are termed covalent bonds. And between metal and non-metals we find ionic bonds. Each type of bond is formed in a different way, so we need to study each in turn. We'll start by looking at how metal atoms transfer electrons to non-metal atoms in order to form ionic bonds. First, we need to know what an ion is. An ion is an atom which has either lost or gained outer shell electrons. Each time an atom does this, the number of protons no longer equals the number of electrons, so an ion has more or less electrons than protons, and so an ion is a charged particle, whereas atoms have no overall charge. Secondly, we need to understand that it is the metal atoms which lose electrons from their outer shell, and the non-metal atoms which gain electrons. This means that metal atoms end up with less electrons than protons, and hence form positively charged ions, while non-metal atoms end up with more electrons than protons, so form negatively charged ions. This is where ionic bonds come from. Opposites attract. Ionic bonds are the electrostatic attractions between oppositely charged ions. Let's look in a bit more depth at how metal atoms form ions. Metal atoms lose electrons from their outer shell much more easily than non-metals, and will continue losing electrons until their outer shell is empty. The number of electrons they lose is the same as their valency, and this is also the amount of positive charge the newly formed ion has. We call this process of losing electrons oxidation. Don't get confused. This use of the word oxidation has nothing to do with oxygen and everything to do with electrons. Here's a lithium atom with one outer shell electron. Once it's given away this electron, it becomes a lithium ion. The outer shell is now empty, and so we can show the next shell in as the new filled outer shell. Having lost one negatively charged electron, the lithium ion has an overall charge of 1+. Notice that the charge is the same as the valency. Non-metal atoms gain electrons by taking them from other atoms and will continue doing this until their outer shell is full. The number of electrons they gain is the same as their valency, and this is also the amount of negative charge the newly formed ion has. We call this process of gaining electrons reduction. Here's a fluorine atom with its 7 outer shell electrons. Once it's taken an extra electron, it becomes a fluoride ion. Notice that it undergoes a name change, getting an "ide" ending to show that it's a negative ion. This doesn't happen with positive ions. Having gained an extra negatively charged electron, the outer shell is full, and the fluoride ion has an overall charge of 1-. Again, the number of the charge is the same as the valency. If we look at the elements which commonly become ions, we can see the ions they each form. Notice again how the valency helps us tell the charge on these ions. Take the time now to pause the video and practice drawing some ions. Remember that for ions we draw them inside square brackets and put the charge on the top right. Here are the answers. Pause the video again to check you're working. It's not easy to use valency to work out the charges of transition metal ions, as these special elements can have more than one valency. We simply need to learn that silver forms Ag+ ions and zinc forms 2+ ions. But for transition elements, we'll usually be told the valency and hence the charge on the ion by including a number in Roman numerals after the ion's name. Thus, copper 1 ions have a 1+ charge, while copper 2 ions have a 2+ charge, etc. Once we know the charges on ions, we have the tools necessary to work out the formula of a substance with ionic bonding. Starting with the name, we write down the ions it's made from with their charges. Then we take the numbers, that is the valency, and swap them over. That's the chemical formula. Note that if the two numbers can be simplified by dividing them by the same amount, we need to do that too. This idea works because the charges have to be balanced in a substance. There has to be as much negative charge as positive charge. So if we have a 2- ion like we do here, we'd need two 1+ ions to balance the charges overall. Time for you to pause the video again and use this idea to practice working out the chemical formula for these substances with ionic bonding. Remember to check if the numbers will divide down any further. The fourth one will, for example, and so will one other. Here are the answers. Pause the video to check your formulae are the same as these. Dot and cross diagrams are used to show the bonding in ionic substances. We usually show only the outer shell electrons, as these are the ones used in forming bonds. We also use dots to show the electrons that came from one atom, and crosses for the electrons from the other atom. The dot and cross diagram shows the charges on each ion and how many of each ion there is, as shown in the chemical formula, and where the electrons are after the ionic bond has been formed. Let's do a worked example. Magnesium oxide is made of Mg2+ ions and O2- ions. If we swap the valencies and simplify, since both divide by 2, we have the formula MgO. This means that we need only one magnesium ion and one oxide ion. We can draw these in square brackets and put the correct charges on them. Now we draw the outer shell electrons for the oxide ion. It started as an oxygen atom with 6 outer shell electrons of its own, which we'll show as dots. It also took the 2 outer shell electrons from the magnesium atom, which we'll show as crosses, so now it has a full outer shell. Finally, we can finish the magnesium ion. We're allowed either to show this as having an empty outer shell, or we can draw the next shell in, which is filled and now becomes the outer shell. Here's another worked example. Hopefully you're getting the hang of how this works. Firstly, from the name to the ions, Ca2+ and Cl1-, so the formula is CaCl2. We needed 2 chloride ions and 1 calcium ion. Now we can fill in the electrons in each of the chloride ions, 7 that they each had as atoms, and the 1 that they each gained from the calcium atom. Finally, the calcium ion, with the next shell in becoming the filled outer shell. Time for some practice. Pause the video and have a go at these. Here are the answers. Pause the video to check your work. Now we turn our attention to covalent bonds formed between non-metal atoms by sharing electrons. Molecules with covalent bonds are very common in our world. The water we drink and the air we breathe contain atoms covalently bonded together. The key idea here is that an atom can gain a share of an additional electron from another atom by sharing one of its own. Non-metals will share electrons in this way until their outer shell is full. Again, we use dot and cross diagrams to show the bonding, but these are different to ionic dot and cross diagrams. The simplest example would be the bond between two hydrogen atoms. Each atom has one electron. By sharing their one electron, they gain a share of one more, so each now has a share of 2 electrons, which is the maximum this shell can hold. We draw the outer shells as overlapping and put the shared electrons, one from each atom, in the intersection. These two shared negatively charged electrons are located between the positively charged nuclei of the two atoms, and therefore hold the two atoms together by electrostatic attraction. Note that there are no ions formed. These are atoms that are bonded together, not ions. Here's another example. Oxygen has 6 outer shell electrons, so can share 2 to gain a share of 2 others that will complete its outer shell. It can do this by forming bonds with 2 hydrogen atoms, each of which wants to share 1 electron. Notice that the number of electrons each atom shares is its valency. Notice that the number of bonds each atom forms is also its valency. Oxygen has a valency of 2 and has shared 2 electrons to form 2 bonds. Hydrogen has a valency of 1, and each hydrogen atom has shared 1 electron and formed 1 bond. As before, we can show the shared pairs of electrons in the overlaps of the outer shells, and the remaining 4 electrons which oxygen has not shared go in oxygen's outer shell, but outside the overlap area. Practice drawing some dot and cross diagrams yourself. Remember that each overlap between the outer shells should contain 1 dot and 1 cross. Then fill in any outer shell electrons which have not been shared. One more tip: if you aren't sure how to arrange the atoms, put the one with the largest valency in the middle, then bond the other atoms to this, remembering that the valency of these atoms is also the total number of covalent bonds it will form. Pause the video now and have a go. Here are the answers. Pause the video and check you're working. Sometimes non-metals with a valency of more than 1 will form a double covalent bond. They do this by sharing 2 of their electrons to gain a share of 2 from another atom. This means there will be 2 pairs of electrons in the intersection of the outer shells. We see this, for example, in oxygen, O2. It's even possible to have a triple bond if the atoms each have a valency of 3 or 4. Pause the video again and have a go at these covalent dot and cross diagrams, which each have a double or triple bond in them. Here are the answers. Pause the video and check you're working. Finally, we need to know about the bonds that form between metal atoms. This is the bonding we'll find in any of the metallic elements such as copper or iron or gold. Metals have a regular layer structure. Each layer consists of positively charged metal ions that have given away their outer shell electrons. Rather than giving these electrons to a non-metal atom, in a metal the electrons simply form a sea of delocalized electrons surrounding the layers of positive metal ions and moving freely throughout the metal. As these electrons are negatively charged and the metal ions are positively charged, there is a strong electrostatic attraction between them, which forms the metallic bond. For metals, we don't need to draw dot and cross diagrams. The simple labelled diagram shown here is appropriate to show the bonding in any metal.